Alright, that's the only thing that you haven't seen before. So the BR2 was used in both half reactions because there's only one reactant.
The aprons are in the way.
You wouldn't just do a single BR, no. Okay? Now we just follow the same set of one step, the whole thing, get it done kind of
Split
thing.
into more steps?
Huh?
Can you like split it into more steps?
Just split the. Let's just keep a tally of how
Into
many
more
steps.
steps?
Alright, let's say
What
for
else would you
example,
do?
that was one step. Alright, so next I have two BRs here. I have
One
one
step
BR,
is
I'm gonna
a-
put a 2 here.
One step process.
Yeah, one step process. So I'm balancing out the first half reaction. Done.
Yeah.
The next half reaction, I need to balance out the BRs.
Uh-huh.
So I'm gonna put a 2 here again.
Yeah.
Now, that's gonna change the number of oxygen.
Yeah.
That changes the number of oxygen, so I'm gonna add waters to balance out the oxygen. You always add water to balance out the oxygen.
Yeah.
So I'm gonna add 6 waters. The reason why I add 6 waters is because with 6 waters I have 6 oxygen.
Yep.
So that balances out the 6 that I have here. Okay? Now, because I added water, I also added 12 hydrogen.
We've been doing this for like 2 weeks.
The 12 hydrogen, I need to balance out by putting hydrogen on the right side.
Yeah.
Okay?
But it's a basic solution.
But, this is a basic solution.
Yep.
So I need to, adding hydrogen is like adding
Hydroxide.
acid. So I need to add the
12.
same amount of base to cancel out the acid.
Yes.
So what I do here is I also got to put in 12 of the base.
Mm-hmm.
The hydroxide means the base.
Yep. And you
Now,
have to add it on the other side.
because I added 12 on this side, I also got to add 12 on this side. 12 OHs. Okay? Now, this thing is a basic solution.
Yes.
Alright? On this side, the hydroxide and the hydronium are going to combine to form 12 waters. Alright? So it forms 12 waters. I can go ahead and cancel out 6 of these waters on this side. 6 out of the 12 waters will cancel out on the right side. Okay? So all of this water will cancel out. Here, only 6 waters will remain. Alright? So let's rewrite the bottom one, I guess. Alright, so the bottom one ends up being 12 OH minus plus Br2, and then that's going to go to 2 bromates plus 6 waters. Alright, once we do that, we balance out the charges. Okay, we balance out the charges. So here, the bromate has no charge. Here, the bromide, there's 2 of them, each one has a -1 charge. So here is going to be -2. The more positive side. Alright, you want me to stop for a moment?
Yeah.
Alright.
You forgot the negative on the BR.
Alright, copy this down.
You forgot the charge.
So would this be step 2?
Huh? This is we're already into like step 6.
It's always step 1. It's all step 1.
Yeah, I know that's how all of those steps turn into one step. I forgot to like number them off. I said, you know what, this is one step.
Yeah. Daniel Ruiz'S one-step process.
Yes. It's Mr. Daniel.
Mr. Daniel. Doctor.
Huh?
Dr. Daniel
Mr.
Ruiz.
Dr. Daniel.
Mr. Dr. Daniel Professor Ruiz.
Alright, something you're not sure
Esquire.
about. Something you're
Sir
not
Daniel.
sure about.
Sir, Mr. Dr. Daniel.
Yes, Alex. Alright, so look, pure substance is gonna have a 0 charge. And it has no negative or positive showing here. Right? This one does have a negative. Each one of the BRs has a negative, but there's two of them because of the coefficient. Okay, so that's how we ended up with a -2 then. Something else? Something. Foster, anything? Fidel Foster. Any questions? No? Alright, Tyrese.
I missed the part where you added the 12 OH.
Oh.
Alright, so when we went to go and balance out the oxygens, right? We had 6 now. I need to make 6 waters on the left side if I can get the 6 oxygen. But that also makes 12 hydrogen.
Okay.
So in order to balance out these 12 hydrogen, I go ahead and put hydrogen on this side. Okay? So that's where the hydrogen came from. Because I added water, that also adds hydrogen, so I gotta put hydrogen on the other side.
And then you just add the OH, the 12 OH after that.
Why did we add the OH?
To balance out, because it's a basic solution.
Ty, why did we add the OH? See, because the hydrogen means that I'm adding acid. And the OH means I'm adding base. And I want to cancel out this acid by adding the same amount of base. The reason why is because this is in a basic solution. Okay?
Yes.
So if I add 12 hydroxides over here, I also have to add 12 hydroxides over here.
Yes.
So if it's an acidic
Okay.
solution, would you add OH before you add H?
No,
What's the
we are
difference?
not
What's
close
the
No.
difference?
to the final answer.
No, you would just add, I'm pretty sure you just add H and then keep it that way.
Because
And you would add
you
H
said
on
you
the
wanted
other
like
side.
super duper
I
explanation, make a teacher
I'm pretty
style
sure,
over here,
yeah, I'm
like,
pretty
I
sure you
gotta
just
do
wouldn't
like
add
this.
OH.
Wait, Mr. Ruiz.
I'm being all-star teacher right now, alright?
So like, what if it was
Huh?
what if it was an acidic solution?
Alright, so, let's say for example, this said that it was an acidic solution. What don't you need?
The hydroxide.
Huh?
The hydroxide.
You would not need the hydroxide,
Yeah.
okay?
Okay.
This would not be here, and this would not be
So
here.
we just keep it as H plus.
The H plus, adding H plus would be fine because you're dealing with an acidic solution,
Okay.
Okay.
okay?
Makes sense.
And maybe we should change that to an acid and see how it turns out. We'll see the differences in both, I
Oh
guess.
god, but we should
See if it's
probably,
even solvable. I don't
we
even
should-
know if it's solvable.
we should
Let's
probably
change that
finish
for now.
this one first.
Alright, let's finish this one. So like we saw here, 0 charge, -2 charge,
Yes.
okay?
Those
So
electrons.
what side gets the electrons?
Right,
The
left.
left. The left.
Said left.
Sean.
Because you gave all options, you're right. Alright, so the left side,
Circle
why the
A
left
through D.
side? The more positive side gets the electrons. Huh? The more positive side gets the electrons. I gotta add enough electrons to make it the same charge as the other. What number do you see here, Mario? Mario, we see a -2. That's why I need to add 2 electrons. They both have negative charges. Alright, so now we go on the second half reaction. What's the total charge on the OHs?
12, -12.
-12, and this here?
0.
0. So I have a -12 over here. And what do I got on the right side?
-2.
Oh, yeah, you're right. I forgot a
Yeah.
little negative. Huh? So yeah, on the bromate there is a negative. So on the right side, there's no charge with the water, but the whole thing, because of the bromate, has a -2 charge.
Yes.
You have to add 2.
So, Demario, how many negatives do I need? Why do you think 6? We're not multiplying that.
He tried.
We're
That was
just
a good try,
adding.
honestly. I respect that.
10 electrons, which way are we gonna go? Which side? On the right side, why? Wait. The more positive side gets it. No, because sometimes, well, like here,
Well, negative means less.
the less. So your explanation is the less side.
No, the side is like without 12. It's if you want to even out. So what do we put on the side?
So, okay, so for example, what if this was plus 4 and this was plus 2? What side would get it?
You put on the right side.
Okay, why?
So you want to even out.
Okay. That would be wrong,
Electrons are negative.
because you need to stick with the idea that the more positive side gets the electrons. This is more positive than this. Okay, so I would have the 2 electrons added to the left side. Okay? So here, negative 2 is much more positive than negative 12. So on this side, we're going to add the 10 electrons. Okay?
Now we combine them.
All right. Nope. Not yet.
Step 1.
So what do you guys want to do next?
Combine them.
You can't combine them yet.
Watch me.
You gotta multiply or combine the electrons.
So you multiply the first reaction by 5.
So what half reaction is gonna get multiplied?
The first one
The first one.
by 5.
The first one by 5. Where did you get this magical number 5?
Because you have to have the same coefficient on the electrons.
Yeah, the coefficient. So for instance, the coefficient here is 10, and then this 2 times 5 gives me 10.
Yes.
Alright? So here, I don't have to multiply by anything.
Yeah.
Because just by simply multiplying the first half reaction by 5 is good enough. I already get those number of electrons to match up. Okay? So now, I'll go ahead and rewrite it all here. Alright, so we have 10 electrons now up on top, plus 5 Br2s. That goes to 10 Brs. And then the bottom, we just rewrite 12 hydroxides plus Br2. That goes to 2 Bro3 negatives plus 6 waters plus 10 electrons. Alright. What cancels?
The electrons.
The electrons for sure. They should always cancel out.
Nah.
The electrons for sure gonna cancel. What else?
No.
Huh?
Oh.
The BRs? What BRs?
No.
BR2.
BR2s cancel?
No, they don't.
Wrong. Why don't they cancel?
Because they're not the same.
They're on the same side. They can only cancel if they're on opposite
Nothing
sides.
else
If they're on the
cancels.
same
Yeah,
side, what happens?
Nothing else cancels.
They
They're
just
gonna
combine.
combine.
Yeah.
They're gonna combine. Anything else
Nothing.
cancels?
Nope.
No? Alright, so in the final answer, we should end up with 12 OHs plus how many BRs?
6.
BR2s. 6 BR2s. And then that's gonna go to 2 BR03s plus the 6 waters
That's the 10.
plus 10 BR negatives. So that's the first time you've seen that, where you combine the like stuff on the left to add up, and that's BR. How come you're not correcting me?
I thought it was BR. No, siento. Don't be here.
Jocelyn, doable?